Hi all, welcome to Greenboard. So today we are going to discuss exercise questions of 1.5, chapter 1.6. Okay. So in the previous video we have already seen exercise up to question number 2. So today from 3 onwards we are going to discuss. So let's move on. So the third question is, here it is given that u is the set of all natural numbers. It is the universal set here. Okay, so the universal set which we are considering today is u, which is the set of all natural numbers. So what all numbers will be included there? It will be consisting of numbers such as 1 2 3 4 5 and so on. Okay, so we have to write the complement of all these given sets. That is our question. Okay, so the first question is, set of all x such that x is an even number. Okay, that is the set which we are given. Okay, we have to write not only the roster form of this set but also the complement of this set. Okay, roster form is our choice, we can write or not. Okay, but definitely we have to write the complement. For the complement also they have said only that we have to write the complement. Okay, so we can write the complement set either in roster form or in set builder form. Okay, so first, if you guys are able to write the complement of these sets from this statement itself, you can write it. Otherwise, first write the answer of this set, that means the roster form of this set, and then translate or find the complement of that set. Okay, so what is this set? It is the set of all x such that x is an even number. So we have to write all the even numbers in the universal set, which is our universal set, set 1 2 3 4 and so on. So what will be our roster form? 2 4 6 8 10 12 and so on. So this is our set, and what will be its complement? Given that the set is the set of all even numbers, isn't it? So the complement will contain set of all odd numbers. Okay, so set of all x such that x is an odd number. That is the complement of this set. Okay, in other words, how we can write 2 4 6 8, and we have to eliminate 2 4 6 8 and from this set. So what will be the remaining elements? 1 3 5 7 and so on, isn't it? So 1 3 5 7 9 11 and so on. Okay, so this is the complement of first one. Okay, then moving on to the next question. What is the question? Set of all x such that x is an odd number. So we have to write the complement of this set. So if you can write, in other words, the answer of the first question can be written in this way also. Set of all x such that x is an even number, isn't it? So what will be its complement? Set of all x such that x is not an even number. Okay, we can tell it in that way also. Otherwise, similarly in this set, how can we tell? Set of all x such that x is an odd number is our set. So what will be its complement? Set of all x such that x is not an odd number. That will be our complement set. Okay, in simple way we can tell like that. Okay, in structured way, how can we tell it? Set of all x such that x is an odd number is our set. So it will consist of numbers like 1 3 5 7 9 and so on. Okay, so what will be its odd numbers is our set. So the complement will be the set of all even numbers. Okay, so set of all x such that x is an even number. That will be our complement set. We can write either even number or even natural number. Both are correct, because here it is given that u is the set of all natural numbers. It is mentioned that we can write only the natural numbers. So if we write here even number or even natural number, both are correct. Okay, so the answer will be 2 4 6 8 10 and so on. Okay, either you can write the answer in this way, or in set builder form like this, or in roster form like this. Okay, so there are 3 type of answers for these questions. Okay, you can follow any of these. Okay, all are correct. And look at the next one. Set of all x such that x is a positive multiple of 3. That is the set builder form of the given set. So what will be its roster form? Here it is given that our set consists of numbers that are multiple of 3. Okay, so what will be the answer? 1 3s are 3, 2 3s are 6, 3 3s are 9, 4 3s are 12, and so on. Okay, so this is our set, and what will be its complement? What we can tell, set of all x such that x is not a positive multiple of 3. Okay, does it mean that x is a negative multiple of 3? In actual way it can mean that it is a negative multiple of 3, but here it is not possible since it is mentioned that our u is the set of all natural numbers. Okay, so what will be the remaining terms? We have to eliminate 1 3 6 from this set. Okay, this is our set. So we eliminated, we have to eliminate the multiples of 3. That means 3 6 9 12 and etc have to be avoided from this set. So what will be the remaining elements? 1 2, then we can't write 3 since 3 is here, then comes 6. So the numbers up to 6 we can write. So 4 5, we can't write 6, then 7 8, but 9 can't be written because 9 is here. So 10 11 and so on. So this is our set. Okay, so here the set builder form is this one. Okay, set of all x such that x is not a positive multiple of 3. Okay, moving on to the next one. What is this? Set of all x such that x is a prime number. We have to write the set of all x which is the prime numbers. Okay, what we mean by prime numbers? Prime numbers are multiples, in other words multiples, the multiples of 1. Okay, we can tell it in that way, only the multiples of 1. Okay, if we write 1 into 6, it is 6, but there is also other option for 6. What is it? 2 3s are also 6. Since there is an option like 2 and 3, we can't write, or we can't say 6 is a prime number. Okay, but for 7, 1 into 7 equal to 7 is the only option. Okay, for 15, 1 into 15 is an option, also there x is 3 into 5. Okay, since 3 into 5 comes, this is not a prime number, it is a composite number. Okay, so prime numbers are numbers that can be written only as a multiple of 1. Okay, all the numbers which can be written as the multiple of other numbers, that means 4 into 3 equal to 12. Okay, these numbers does not becomes prime, they will be composite numbers. And there is an exceptional case also, that is 1. For 1 is neither prime nor composite. Okay, so 1 can't be written as a prime number as well as composite number. Okay, so here our set is set of all x such that x is a prime number. So 1 can't be written since it is neither prime nor composite. 2 can be written because 2 is the smallest and also the only even number. Okay, even prime number. Then 3 4 6 8 etc can't be written because all the other even numbers than 2 will be the multiple of 2. So all the other even numbers will have a factor 2, so they can't be written. So we have to consider only the odd numbers, but all odd numbers are not prime because there is 9 can be written as 3 into 3, but it is not prime. Okay, so we have to consider except 2 only the odd numbers. So 5 7 9 can't be written because there is 3 into 3. Then 11 15 can't be written because there is 3 into 5. Then 17 19 21 can't be written because 7 3s are 21. Okay, so this is the our set, and we have to write the complement of this set. So what will be its set of all x such that x is not a prime number. We can't write that set of all x such that x is a composite number. If we write set of all x such that x is a composite number, we will get all the elements between these elements, but we don't get 1, but 1 have to be included in the complement of this set. So because of that, we can't write the complement as set of all x such that x is a composite number. So the complement of this set will be set of all x such that x is not a prime number. Okay, so what will be the answer? 1. Then 2 3 can't be written, So 4, 5 can't be written because 5 is here. Then 6, 7 is here. Then 8, 9, 10, 11 is here. So 12, 13 is a prime number. Okay. Then 14, 15, 16, 17 is here. Then 18, 20 and so on. Okay. So this will be our set. Okay. Then moving on to the next one. What is the question? Set of all x such that x is a natural number divisible by 3 and 5. So first we have to write this set. Okay. Otherwise how can we write the answer? Set of all x such that x is not a natural number divisible by 3 and 5. That becomes our answer. In other words, how can we write it? In step by step form. First we have to write the roster form of this set if we want only. Okay. So set of all x such that x is a natural number divisible by both 3 and 5. Okay. So the number which we are going to write should be in the multiplication table of 3 as well as 5. So first let us write the multiplication table of 3. So what all elements will come there? 3's multiplication table. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45 and so on. This is the multiplication table of 3. And for 5 what it is? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55 and so on. Okay. So we have to write the elements that comes in the multiplication table of both 3 and 5. So let us look at those. So 15 comes in the multiplication table of 3 and 5. Then comes 30. 30 comes in the multiplication. So first number is 15 and after 15 only 30 is coming and after that only 45 is coming. Okay. So our answer is 15, 30, 45 and so on. So what is this? 15 into 1 is 15, then 15 into 2 is 30, 15 into 3. So what will be the next one? 15 into 4. So this is the multiple of 15. Okay. So how can we write our complement set? Either we can write set of all x such that x is not a natural number divisible by 3 or 5. Otherwise how we can write set of all x such that x is not a multiple of 15. Here the given set is a multiple of 15, so its complement set will be not a multiple of 15. And in roster form how we can write it? 1, 2, 3 up to the first number is 15, so we can write up to 14. And ignoring this 15 we can start from 16, 17 onwards up to 29 because 30 is here. Okay. Then excepting 30 we can write 31 and so on up to 44. Then from 46 it continues. Okay. So this is the answer. So our next question is set of all x such that x is a perfect square. Okay. So how can we write its roster form? Roster form of perfect square means the answers of numbers 1 into 1, 2 into 2, 3 into 3 and so on. Okay. So 1 1s are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25 and so on. This forms our perfect square. Okay. So what will be its complement? Set of all x such that x is not a perfect square. That forms the complement in set builder form. Okay. Then how it will be in roster form? After 1 it is coming 4. So the between elements, what are they? 2 and 3, as well as after 4 it is coming 9. So the elements 5, 6, 7, 8. Then after 9 it is 16. So 10, 11, 12, 14 and up to 16. Then we can't write 16, we have to write up to 15 only. Then after 16 it is 25. So we can write all the elements up to 25. starting from 17 we can write up to 24. Okay, 24, and we will continue in this manner. So this forms our complement of set of all x such that x is a perfect square. Okay, then what is the next one? Set of all x such that x is a perfect cube. Okay, so we have to multiply 3 times the same number and it forms a cube. That means 1 into 1 into 1, 2 into 2 into 2, that is 8, and 3 into 3 into 3, that means 27, 4 into 4 into 4, which is 64, 5 cube, which is 125, and so on. So this forms the set of all perfect cubes. Okay, then how will be its complement? Set of all x such that x is not a perfect cube. That will be the complement of perfect cube set. Okay, so all the elements except these elements in the natural set can be written. Okay, so after 1, 8 is coming. So all the between elements, what are they? 3, 4, 2, 3, 4, 5, 6, 7. Then we can't write 8 since it is in this all normal set. So in the complement set, from 9 onwards we can write up to 26. Okay, since 27 is here, we can start again from 28 up to 63, and this pattern continues. Okay, so this forms the complement of this set. Okay, then moving on to the next one. What is the question? Set of all x such that x plus 5 equal to 8. So in direct manner, how can we tell its complement? Set of all x such that x plus 5 not equal to 8. That will be the answer. But before that, let's look at the answer of this set, otherwise the roster form of this set. So we have to solve this expression, and the value of x which we get, that forms the roster set of this set. Okay, so what is our set? X plus 5 equal to 8. So we have to find the value of x. That means we have to write x equal to. Okay, so other than x equal to, what we can see here, it is plus 5. Okay, so we don't need plus 5 here, we need only x equal to. Okay, in this side we need only, in the LHS we need only x equal to. All the elements other than x and equal to can be erased from this side. So what all elements we erase? We can't erase it. Okay, we can only replace it. So plus 5 have to be replaced, plus 5 have to be moved to this side. Okay, so when we move a number, the number will remain the same, but the operation changes to its reverse operation. So the opposite of plus is minus. Okay, subtraction. So the plus 5 when it comes to the RHS, that means right hand side, it will become minus 5. So x equal to 8 minus 5, which is 3. Okay, so the answer is 3. The roster form of this expression is 3. So our set is 3. Then what will be its complement? All the elements in this natural set except 3 can be written. So 1, 2, without 3, 4, 5, 6, 7, 8, and so on. This forms our set. Okay. Then moving on to the next one, what it is? Set of all x such that x greater than or equal to 7. That is the set. So what will be its complement? Set of all x such that x not greater than or equal to 7. Okay, that will be the answer. But let's look at it. Okay, so by telling greater than or equal to, set of all x such that x should be greater than or equal to 7. So since there is an equal to, 7 can come, then all the elements in this set should be greater than 7. So what all should be them? 8, 9, 10, 11, and so on. So this is our set. And what will be its complement set? All the elements in the universal set except this one we can be written. Okay, so from 7 onwards all elements are present in this set. So from 1 onwards 6 we can write, and that forms the complement of this set. Okay, then comes the next question. What it is? 2x plus 5 equal to 9. So what will be its complement? 2x plus 5 not equal to 9 will be its complement. Okay, in other words, how we can tell it? We have to find the roster form of this set. Okay, so we have to solve it. What it is? 2x plus 5 equal to 9. Okay, so here first we will get the answer of 2x, then we have to find the answer of x. So first we have to make it in such a way that only 2x equal to exist in this side, and balance everything have to be moved to the other side. Okay, so here it is 9 is present there. So what is the other thing present here? It is plus 5. So we have to replace it to the right hand side, then it will become minus 5. Okay, so what is the meaning of 2x? 2x means 2 into x. So 2 into x means 4. Then we will get x equal to. So 4 is present here, the exceptional case. That is into 2. So when we move it to here, 2 will remain as 2, but multiplication will change to its opposite operation, which is division. So x equal to 4 divided by 2, or in other words 4 by 2, which is 2. Okay. So the roster form of this expression is 2. Then what will be its complement form? All the natural numbers except this 2 can be written as its complement. So 1, 2, 3 up to without 2. Okay. So 1, 3, 4, 5, 6, 7 and up to this continues. Okay, so that is the answer of this question. And moving on to the next one, here it is given that x belongs to n. Okay, but without saying x belongs to n, we already knew that the answer belongs to n. Since it is mentioned here, our universal set is set of all natural numbers. Okay, so here we have to, how can we tell its roster form? Set of all x such that 2x plus 1 not equal to 10. That is the roster set builder form of its complement. Okay, in other words, how we can tell, or in step by step manner, how we can solve it. First we have to find the roster form of this given set. Okay, for that we have to solve 2x plus 1 greater than 10. Okay, for CBSE as well as ICSE students, they know how to solve this inequality, but state students are not familiar with this sign. Okay, solving these signs. Okay, but it is same as solving the equal to sign, and you will study about this in detail in a coming chapter named inequalities. Okay, so here just solve it by placing the inequality. Here the inequality is greater than, place the greater than in the middle and solve it like the equal to itself. Okay, so here first we will get the value of 2x. So we need only 2x here, and what is the extra part here? It is plus 1. So when we move to this side, it will become minus 1. So 2x means 2 into x. 2 into x is 9 here. So 9. Then we have to move this into 2. That is the extra part now here. So when into 2 is moved to this side, or if we replace it to here, it will become 9 by 2. Then it will be 4.5. So all the elements greater than 4.5 forms our set. Okay, if 4.5 can't be written, we can't write 4.75. 4.5, what is the meaning of 4.5? It is 4 and a half. Okay, if we can't write 4 and a half, then we can't write 4 and a 3/4. Okay, because in our universal set, if we can't write 4, then the possible element is 5. So here it is said that 4.5, the number which we are going to write should be greater than 4.5. So 4 and a 3/4 is greater than 4.5, but we can't write it here since our universal set is natural number. So after 4.5, our only option is 5. Then 6, 7, 8 and everything can be written. If 6 is greater than 4.5, 6 and a half or 6 and a quarter, all are greater than 4.5. But here, since our mentioned universal set is natural numbers, we can't write them. Okay, so our set is 5, 6, 7, 8 and so on. So what will be our complement set? Set of all x such that 2x plus 1 not greater than or equal to 7. So 1, 2, etc. up to 4 we can write. 1, 2, 3, 4. That is our complement set. Okay. This style of writing, that means by negating, writing a statement to its opposite meaning just by adding a word. Okay, just by adding one word, we are converting this sentence to its direct opposite meaning. Okay, writing it in that way, it is called negating a statement. Here all the negations of these statements will make the complement. Okay, simply how can we write it? Just negate this statement. Okay, otherwise we can write it in this way also. Okay, so let's move on to the next one. So our next question is, it is given that u equal to set 1 2 3 4 up to 9 and two sets A and B are defined here, and we have to verify the two given expressions. What are they? A union B whole complement equal to A complement intersection B complement, as well as A intersection B whole complement equal to A complement union B complement. We have to verify whether these two things are true. Okay, so to verify a expression we have to solve its left hand side, that means LHS, as well as right hand side, which is RHS. Okay, and when we get the answer of both LHS and RHS as equal, then we can tell it is verified. If equal to is given here, sometimes greater than or sometimes not equal to will be given. So depending upon the sign, when the expression we solved is correct, then we verified it. Okay, so here it is equal to. So while solving A union B whole complement as well as A complement intersection B complement, we have to get the same answer. Okay, this question can be solved in two manners. Okay, by theory part as well as by drawing Venn diagram. Okay, here I am doing the both and you can choose whatever you like. Okay, so first we have to write A union B. Okay, so while writing a question, since it is an exam mode, okay, so while writing in exam pattern, we have to write the given data present in a question. So while writing the answer, you have to mention U, A and B for each sub question. This is the first one here. So I mentioned U, A and B in the question. Okay, so then we have to solve A union B whole complement. So for that, first we have to find the union of A and B. So what will be the union of A and B? All the elements that are present in A as well as in B. Okay, so what are the elements present in A? First we are writing the elements present in A and we finished it, and with this we have to add all the elements that are present in B also. So what are they? 2. First element is 2, but we don't have to write 2 again, since in a set by definition we know that there is no order as well as repetition. So 2 is already written here. So 3, 5, 7 have to be added. So this forms the A union B, but what we need is the complement of A union B. Okay, so all the elements present in U that are not in this A union B have to be written. Okay, so 2, 4 here, 2, 4, 6, 8, then 3, 5, 7. 3, 5, 7 have to be ignored. Then what are the remaining elements? They are 1 and 9. So this forms our LHS, which is A union B complement. So I am marking it as 1 here. Then we have to find A complement intersection B complement. So first we are finding A complement. So what does the term A complement means? All the elements present in U, but they are not in A. They should not be in A. Okay. This is our set, and our A contains what all elements? A contains the elements 2, 4, 6, 8. So how can we tell it in roster form? It is the set of all even numbers that are less than or equal to 9, isn't it? So the complement will be set of all odd numbers that are less than or equal to 9. So 1, 3, 5, 7 and 9 forms the complement of A, and we have to write the complement of B also. Here B is 2, 3, 5, 7. So except 2, 3, 5 and 7 we can write all the elements. Okay, so what are they? 1, 4, then 6, 8, 9. 6, 8 and 9. This forms our B complement, and here what we have to find the intersection of both A complement and B complement. That means the common elements, the elements that are present in both A complement as well as in B complement. But so by observing these sets we can understand that 1 and 9 are present in both. Okay, so our answer will be 1 and 9, and this is so this is our set 2. equation 2. Here when we look at both, we can understand that 1 equal to 2. So we can write verified. This is the way to solve it in theory manner, and we can solve it in Venn diagram manner also. Okay. So to solve Venn diagram manner, there are two sets that are A and B present. So we have to draw two circles A and B. Okay. One should be named as A and other should be named as B. So this will be the outline of our Venn diagrams. Okay. How it is? The rectangle shows the universal set and two overlapping circles are drawn, and one is named as A and one is named as B. Okay. Then what is our A? A contains 2, 4, 6, 8, and B also contains 2, isn't it? So 2 have to be right in this common region. Okay. 2 is present in this common. Then what forms our A? A contains 4, 6, and 8. Okay. Other than 2, there is 4, 6, and 8. So this forms our A. This whole circle forms our A. And what are the elements present in B? Other than 2, there are 3, 5 and 7. So this circle forms our B. Okay. 3, 5 and 7 is present. Then by looking it, we can understand that 1 and 9 are not written in both these circles. So that two elements have to be written outside the circles but inside the rectangle. So this forms our Venn diagram representation of these sets, and we have to represent A union B complement as well as A complement intersection B complement. Okay. So we are going to represent them. So first we have to represent A union B, the complement of A union B. Okay. So what is A union B? A is this set and B forms this set. This is A and this is B. So all the colored region, okay, every colored region together forms A union B. So the exceptional part, that is this orange colored part, will form the complement of A union B. That means A union B complement. Okay. Then we can write it here also by drawing a mark from there. We can write it is A union B. Okay, if needed. So by drawing it, we understood that 1 and 9 are present in the complement. Okay. Then after that, we have to show A complement intersection B complement. Okay. It can be shown in one Venn diagram. For your understanding, I drew two diagrams. Okay. In first one, first I will show the complement of A. So what forms our A? This circle forms our A. This red color circle is A. So what will be its complement? All the other parts except this red circle. Okay. That is our complement of A. Okay. So this yellow region forms the complement of A. Similarly, we have to find the complement of B also. What is B here? This red color circle forms the B. Okay. So all the other regions that are outside this red circle forms our complement of B, and that is this part. Okay. So the union of both these parts, okay, we have to draw the union of both these parts together. Okay, so how will we come here? 1/2 moon more has to be added here and here also. Okay, so this petal region, only this petal region, okay, we have to find, sorry, this was a mistake, we have to find the complement here. Okay, just a minute. This is how our set is given, and what we have to write is the common elements that are present in here. When we look at it, we can understand that this half moon shape is not present here, and this half moon shape is not present here. Okay, also this 2 is not present in both. Okay, so by accepting these elements, then what will be the common elements that are present in both? They are 1 and 9. Only 1 and 9 are present in both these questions. Okay, all the others are either in A or in B. Okay, so the common elements are 1 and 9, then that forms the Venn diagram of this part. Okay, then comes the next one, and first let us look at the Venn diagram. So first we have to draw rectangles, and we are marking we have to mark the two circles and have to write the elements. Okay, so let us do it. So here in this question, first we have to find the intersection, the complement of A intersection B, that is the left hand side here. So for that, first we have to find A intersection B, that means the common region that is present in both. What it is this one, isn't it? So this is the common region present in both, which means it is 2. Okay, so what will be the complement of this one? All the elements that are present outside this petal region. Okay, everything. Okay, in this rectangle, everything other than this white petal region. So what will be the elements? It will be the set A intersection B is set 2. So A intersection B complement equal to set 1, 3, 4, 5, 6, 7, 8 and 9. Okay, so this is our first equation. Okay, then how we can draw the other one? First we have to find the A complement. Okay, so what forms the A complement? A complement, that means all the elements that are present outside A. Okay, so what is A here? This green circle, otherwise this blue circle forms the A, and all the other elements that are present outside this circle. Okay, or everything other than this blue circle, that forms our A complement. Okay, so what are they? A complement equal to set 1, then 3, 5, 7, 9, that forms our A complement. Similarly we have to do B complement also. So first we have to understand what is B. So B is this circle. Okay, this is the B, and what will be the complement of B? Everything except this blue circle. So this forms our B complement. Okay, so what it is? Taking another color. B complement is 1, 4, 6, 8 and 9. This is our B complement, and what we need is A complement union B complement. So we have to write, otherwise we have to mark all the elements that are present in either A complement or in B complement. So 1, then 3, 4, 5, 6, 7, 8 and 9. This forms the union of A complement and B complement. So this is 2. By looking both 1 and 2, we can understand that both are equal. So verified. Okay, when you are doing this question for exam, first you have to mention U, A and B. Okay, so what is our U? Set 1 to 9, that is our U. And what is our A? Set of all even numbers. And what is our B? Set 2, 3, 5, 7. This is how you have to answer it for exam. Okay, so with this question I am winding up today's session, otherwise the video will become so lengthy. Okay, so thank you for watching Green Board. See you again.